Good morning, children. In today's class, we are going to learn about matrix. Matrix is an array of elements. So we can write a matrix with numbers, positive, negative, anything can come, or elements like A, B, C, A square, B square, C square, minus A, minus B, minus C. So, these arrangements here, there are two rows, row 1, row 2, and there are 3 columns. Here we say there are 3 rows and 3 columns. This we call a square matrix where the number of rows and number of columns are equal. This is a rectangular matrix. What else have you studied about matrices in standard 10? You can have a matrix like this: A, B, D, some numbers. Here we have only zeros. How do you call this matrix? We have only diagonal elements. The other elements are zero. A matrix in which elements, non-zero elements are present only along the main diagonal is called diagonal matrix. The next idea, suppose all are equal. I have A. All the 3 elements are equal. The diagonal matrix is becoming scalar. The word scalar is a constant. So diagonally, same elements come. I call it as a scalar matrix. Suppose instead of A, B or C, I have 1 in the diagonal. I call it as an unit matrix. So we specialize the names when it has different elements. Along the diagonal alone, I call it as a diagonal matrix. When all the diagonal elements are same, I call it as a scalar matrix. And if all the diagonal elements are 1, the number 1 is called unit matrix. This is also a diagonal matrix. This is also a diagonal matrix, but specializing. Because it is same along the diagonal and other elements are 0, we call it scalar. Because it is 1 along the main diagonal and other elements are 0, we call it as unit matrix. Unit matrix, we give a special name I. I stands for identity. Now how many rows are there? 3. How many columns are there? 3. So unit matrix is of order 3. I3 we denote. That is called identity matrix or unit matrix. When I say unit, there is a question whether there is a null matrix. How do you write the null matrix? We call all the elements to be 0. There is not even one non-zero element. What about this matrix? Is it 0? No. There is at least one number present. Non-zero element is present. This is not 0 matrix. Whereas this I call 0 matrix. 0 matrix can be of any order. Here it is 2 by 3. I can write 3 by 3. So 0 matrix we denote capital O. O represents 0 matrix or null matrix. Suppose I have only one row. 4 columns. This is called row matrix. The same idea if I have like this. There are 4 rows but only 1 column. This is called column matrix. So we have row matrix contains only 1 row but any number of columns. Column matrix contains only 1 column. So 1, 2, 3, 4 rows are there but there is only 1 column. So we have learnt a variety of matrices. What all? Let us give example for each matrix and understand the concept well. Triangular matrix. The word triangular like this way. So it may be like this or like this. So elements are present only here. All these elements are 0. See, I can have 1, 2, 4, -3, 5, 7. See, elements are present here, whereas here there are only zeros. Above the main diagonal, the answers are 0. The same idea, below the main diagonal, my answer may be 0. This is also a triangular matrix. Now, my answer may be like this. So, this is upper triangular matrix, whereas this is lower triangular matrix. Now, as we see the matrices, we must be able to identify to which type it belongs. Matrix is a rectangular array of elements. So let us give a name A equal to capital letters we use to denote a matrix. Here I am having some example 1, 4, 0, -3, 7, 9. Order of a matrix. How many rows? 2. How many columns? 3. Row matrix. Give an example. Only 1 row. 1, 7, -3, 0, something like this. Column matrix. We write only 1 column. So 1, 4, 9. Square matrix will be of same rows and same number of columns. So we have an example 405 -389 132. This we call B matrix. Some name I am giving. Diagonal matrix. Only diagonally elements are present. 1, 7, 9. The remaining elements are 0. Scalar matrix. Diagonally, we have same elements. The other elements are 0. So, diagonal matrix also diagonally same elements, no? Diagonally non-zero elements. Scalar matrix tells diagonally same elements. Unit matrix we denote as I. It can be like this 1, 0, 0, 1. 2 rows, 2 columns. Call it I2. You also have I3. How to write I3? It is 1, 0, 0, 0, 1, 0, 0, 0, 1. The next comes 0 matrix. How to write 0 matrix? We denote it as O. And we can write all entries to be zeros. It can have any order. Triangular matrix. We have 2 types, upper and lower. In upper triangular matrix, we have like this 1, 2, 4, 0, -7, 9, 0, 0, 3. See, upper triangular matrix. The lower triangular matrix, the same idea. We have 1, 2, 4. Diagonally elements are present. So 7, this is 0, 0 and 0, 8, 9, even negative numbers can come. So this is lower triangular matrix, whereas this is upper triangular matrix. Negative of a matrix. Let us take A. The negative tells me it is minus A. Just change the symbols. 1, 4, 0 will become minus 1, minus 4, 0. Minus 3, 7, 9. Change the symbols. 3, minus 7, minus 9. So minus A, negative of a matrix, change the symbol of every element of A. Transpose of a matrix, we denote it as AT. Transpose tells me rows and columns interchange. So I will write 1 minus 3, 4, 7, 0, 9. Addition. Can you add these two matrices? A plus B is possible? No. A has 2 rows and 3 columns, whereas B has 3 rows and 3 columns. If I want to add, A and B must have same order. Then only addition or subtraction is possible. So this is having 3 rows and 3 columns. We can add these two. How will you add? Corresponding entries. 4 plus 1, 0 plus 0, 5 plus 0 is 5. Similarly, second row and second row. Minus 3 plus 0, 8 plus 7, 9 plus 0. Third row and third row. 1 plus 0, 3 plus 0, 2 plus 9. The same idea. This is B plus C I have done. You can also write B minus C. What is B minus C? Subtract. 4 minus 1, 0 minus 0, 5 minus 0. Second row and second row. Minus 3 minus 0, 8 minus 7, 9 minus 0. Third row and third row. 1 minus 0, 3 minus 0, 2 minus 9. So addition and subtraction can be done only if they are of same order. The next idea is multiplication of matrices. Multiplication can be done by row by column. You have done in standard 10 how to multiply matrices. First row by first column. First row by second column. First row by third column. Same idea we do with second and third. So we can do only row by column. Here it is 2 by 3 A matrix. Then I can multiply B matrix, which is 3 by 3. When I multiply the 2, 3 and 3 will get cancelled. My answer is 2 by 3. So AB matrix will be of the order 2 by 3. Remember, we can do row by column. First matrix columns must be equal to number of rows of second matrix. These two I cancel and I find my answer as 2 by 3. Equality of matrices. When will you say two matrices are equal? Here any of these matrices are equal given? No. Equality tells me order must be same also. The elements, corresponding elements must be same. So for this matrix, if I want to write an equal matrix, I can have like this way. Instead of 1, I can write 2 by 2. 0, 0 only. Instead of 7, I can write 14 by 2. 0. Instead of 0, I can write 1 minus 1. Instead of 9, I can write 11 minus 2. So we compare C and E. The corresponding entries must be equal. Then only we call equal matrices. So let us see the idea. Matrix has rows and columns. Horizontally rows, vertically columns. We have learnt all these in standard 10. Then what is new this year? We call the term determinants. Determinants. What is a determinant? It is a value associated with every square matrix. So determinants can be done with only square matrices. What do you mean by the word square matrix? The order will be 2 by 2 or 3 by 3. 2 rows and 2 columns. 3 rows and 3 columns. So these are called square matrices. Let me call this as A and B. What I want is determinant. So how to find out the determinant? First of all, the notation. Put A within 2 lines. You call this as determinant of A. How to find it? Multiply the 2 elements. 7 into 3. Subtract 1 into 8. So how to find the determinant? Multiply these two minus multiply the other two. 7 3s are 21. Minus 1 into 8 is 8. 21 minus 8 is 13. So determinant A is a value. It is not a matrix. A is a matrix, whereas determinant A is a number. And I can find this number only with square matrices. To find out the determinant of B, we should know certain words called minor. How to find minor? Minor. See, you are all minors below 18 years. You are submissive to your parents. The same idea, minor of a matrix when I say. You hide a particular row and a column, and the remaining we call minor. So here I want minor of 5. Where is 5 coming? It is in second row, hide it. It is in second column, hide it. So what is remaining? 1, 3, 7, 9. I hide the second row and hide the second column. The remaining are 1, 3, 7, 9. Find the determinant, and that we call minor of 5. So expand the answer. 1 into 9, 9. 7 3s are 21. 9 minus 21. So minor is again a number. It is also a determinant. Tell me another example. Minor of 9. Which one should I hide? 9 is coming in third row. Hide it. 9 is coming in third column. Hide it. What is remaining? 1, 2, 4, 5. Expand it. 5 minus 8. My answer is minus 3. So minor, if you want, suppress or hide the row and column where the element is present. Now, for every element, I can find minors. There are 9 elements. So I can find out 9 minors. After finding minor, we put a symbol for minor and call it as cofactor. How to find it? A 3 by 3 matrix. To find cofactor, I call it as signed minor. Cofactor is nothing but signed minor. What is this sign? First row, first element. Where I am now? First row, first element. Add these two. 2. 2 is an even number. Give the symbol plus. 2 is coming in first row, second column. First row, second column. Add these two. My answer is 3. Odd number, put negative. What about 3? First row, third column. So it is 4. Even number comes positive. Now you can easily tell me this will be negative, positive, negative. Third row, positive, negative, positive. We know first row, first element. So this is A11. Adding these two, even number implies positive. This is A12. First row, second column. Adding these two, odd number tells me minus symbol. A13. Adding these two, even number, so it tells me positive. Plus, minus, plus. How does it come? We put minus 1 power I plus j, where I stands for the row and j stands for the column. I represents the row in which the element is present. J represents the column in which the element is present. I plus j, say 1 plus 1. It is even. My answer is positive. It is odd. My answer is minus 1 power odd number is negative. So my answer is either plus symbol or minus symbol. With this symbol, put the minor. Cofactor, first I have to assign the symbol and then I must find the minor. So every term should be filled by the minors. So let us see some examples. Example 1.3. Find the minor and cofactor of each element in this matrix. 3, 1, 2. 1, 2, 5. 4, 1, 0. First, I want to find out minor of M11 tells me first row, first column. So 3. Hide the row and column. What is left out? 2, 5, 1, 0. Simplify the answer. Multiply 0. Multiply 5. In between minus. Multiply 2 and 0. Multiply 1 and 5. This product minus this product. So what is my answer? Minus 5. Cofactor. How to write cofactor? It is 1, 1. So add the two numbers. 1 plus 1 is 2. Even number tells me positive of minus 5. So my answer is minus 5. Same way, tell me minor of 1. What is minor of 1? It is M. Minor, I can denote capital M. Where is 1 coming? First row, second column. Now I am here, not here and all. Here. So it is first row, second column. I write M12. Hide first row and second column. What is left out? 1, 5, 4, 0. Expanded 0, minus 20. My answer is minus 20. But when I write cofactor of 1, it is A12. 1 plus 2 is 3. Odd number tells me minus symbol. And my answer here is minus 20. Minus into minus is plus. So I get plus 20. Same way, proceed for the next element. Minor of 2. I call it is M13. First row, third column. Hide first row and third column. 1, 2, 4, 1. Multiply 1. Multiply these two, 8. 1 minus 8 is minus 7. When I come up to cofactor of 2, it is A13. 1 plus 3 is 4, even number. Even number tells me positive. Plus of this answer, minus 7. So it is minus 7. Like this, proceed for the second row and third row. Minor of 1, M21. Here I am. hide second row, first column. I am left with 1, 2, 1, 0. 1, 2, 1, 0. Multiply 1 into 0 minus 1 into 2. My answer is minus 2. Cofactor A22. A21. 2 plus 1 is 3. 3 is an odd number. So my answer is minus of minus 2, which is plus 2. Now I want minor of 2. Where is this 2 present? Second row, second column. So when I hide second row, second column, I am left with 3, 2, 4, 0. 3, 2, 4, 0. Expand the answer. 3, 2, 4, 0. 0 minus 8. So it is minus 8. When I come to cofactor 2, 2. 2 plus 2 is 4. Even number tells me positive. Plus of minus 8 is minus 8. Same way, we go on to the third element 5. Where is 5 coming? Second row, third column. What is left out? 3, 1, 4, 1. 3, 1, 4, 1. 3 minus 4, my answer is minus 1. But what about A23? Second row, third column. It is 5, odd number. So it is minus. Minus of minus 1 is plus 1. 4. Where is 4 coming? Third row, first column. What is left out? 1, 2, 2, 5. 1, 2, 2, 5. 5 minus 4, that is 1. A31, cofactor of 4. 3, 1. Total is 4. 4 is an even number. So plus 1 equals to 1. Try to fill the remaining and check your answer. A32 is 3 plus 2, 5. Odd number gives me minus symbol. A33. So cofactor we denote capital A and minus we denote capital M. This 2, 3, 3, 1, 3, 2 and all tells me which row and which column. So for all the 9 elements we have found out the answer, and as we tabulate, you call it as a cofactor matrix. So in the next problems, we will not be doing all these steps. We will do it in a little more shortcut and call that as Mij. This is called minor matrix of A. And Aij tells me cofactor matrix of A. So Mij is a minor matrix. Every element in the matrix replaced by the minor. Aij tells me cofactor matrix of A. Every element in the matrix is replaced by the cofactor.